Tunisia, April 1943. The desert night was silent except for the grind of chains against sand. A captured German Tiger tank, number 131, was being dragged by Churchill recovery vehicles under the cover of darkness. Its engine had long gone, cold, but the air still carried the faint scent of scorched oil and iron. British soldiers watched in awe as floodlights revealed its hulking frame, 57 tons of welded arrogance. The armor glinted under lantern beams, thick enough to mock most Allied shells. Yet tonight, it wasn't the armor they cared about. It was what lay inside. Crated and ferried north through the Mediterranean, the Tiger reached England like a fossil from another age, a mechanical beast to be dissected. In a quiet workshop at Farnborough, engineers stood around the exposed gearbox, their breath turning to mist in the chilled air. A metallurgist turned the steel gear under his lamp, and at that moment, the first clue emerged about why the Tiger had seemed almost unstoppable. By late 1942, the war had entered a new and brutal phase. In the deserts of North Africa, the British Eighth Army was finally gaining momentum after the victory at El Alamein. Yet, as Allied forces advanced westward into Tunisia, new reports began filtering through the field channels. Stories of a strange, massive German tank that shrugged off direct hits and struck back with surgical precision. They called it the Tiger. At first, Allied intelligence thought it was just another rumor, soldiers exaggerating the battlefield. But by December 1942, frontline units near Medjez El Bab and Hunt's Gap were sending in photographs, fragments of armor, and field sketches. Tank crews reported rounds ricocheting off the enemy's turret at near point-blank range. Anti-tank guns that once shattered Panzer IIIs and IVs now sparked harmlessly against something altogether new. For the British War Office, this was an unsettling revelation. The Tiger E, officially the Panzerkampfwagen 6 Tiger Ausf. A, had appeared months earlier on the Eastern Front, but North Africa brought it within the grasp of the Western Allies for the first time. Commanders realized this wasn't merely another step in tank design. It was a quantum leap. Designed under Henschel with the famed 80mm KWK 36 L56 gun, the Tiger combined firepower, armor, and precision engineering that seemed impossible under wartime constraints. It wasn't fast, but it didn't need to be. It could engage enemy armor from well beyond return fire range. In open desert, that advantage was devastating. The tank's appearance in Tunisia sent shockwaves through Allied command. Technical branches in London wanted one, intact. That opportunity came in April 1943, during the fighting around Jebel Jaffa near Medjez El Bab. The Tiger numbered 131, belonging to the 504th Heavy Tank Battalion, was struck by a 6-pounder shot that jammed its turret and wounded its crew. The rest of the battalion withdrew, leaving the immobilized giant behind. For British troops on the ground, it was a trophy unlike any other. For engineers back home, it was a gift from the enemy's own forge. Within days, teams from the Ministry of Supply and the Department of Tank Design were dispatched to secure the vehicle. Photographs show the Tiger half buried in Tunisian dust, its turret frozen at a crooked angle, tracks broken but hull intact. Once recovered, it was loaded aboard a ship bound for England under heavy guard. Every bolt, plate, and component was catalogued as if handling a fallen king. When it reached the docks, the tank was transported to the fighting vehicle proving establishment at Chertsey. Here, it would face the calm scrutiny of British engineers, the men whose job was to translate awe into analysis. They had studied captured German tanks before, but this was different. This was the most advanced armored machine the Wehrmacht had ever produced. The first tests were simple: measuring armor thickness, checking shell resistance, mapping weld quality. But what intrigued them most wasn't visible from the outside. It was the way it moved. Reports from Allied tank crews described the Tiger's uncanny ability to pivot on its axis, its turret slewing smoothly while the hull barely trembled. Even in mud or rough terrain, it advanced with a kind of deliberate grace. No grinding, no violent gear changes, no track shudder typical of heavy vehicles. That level of control demanded more than brute force. It hinted at a powertrain unlike anything in Allied service, and so, a request went out for metallurgical analysis. The gearbox, transmission, and steering system would be dismantled piece by piece, every component weighed, etched, tested, and documented. The goal was to uncover the heart of German engineering, excellence, and if possible replicate or counter it. In the following weeks, British scientists began the painstaking process of disassembly. Under laboratory light, they examined the Tiger's Maybach HL230 engine, then moved deeper into its Maybach Olvar OG40 12-16 gearbox. The parts gleamed, with precise machining, helical-cut gears, hardened steel teeth, and flawless surface finishes that betrayed both craftsmanship and metallurgy. The team realized immediately that the Tiger wasn't built for efficiency. It was built for perfection, even under battlefield duress. And as they prepared to dig deeper, one question lingered. What kind of engineering mindset would devote such effort to something destined for destruction? The captured Tiger stood like an altar to engineering. Panels were removed one by one, bolts neatly lined on trays marked in chalk. Each component, from the turret gear ring to the final drive, revealed a glimpse of Germany's industrial obsession. Precision without compromise. In the center of it all sat the Maybach Olvar OG40 12-16 gearbox, a masterpiece in its own right. To an untrained eye, it was just a massive block of steel and cogs. But to the British metallurgists and design engineers huddled around it, this was where the Tiger's soul lived. The Olvar wasn't an ordinary manual gearbox. It was a preselector, type, a system that allowed the driver to prepare the next gear and shift smoothly with minimal effort, 8 forward speeds and 4 reverse, hydraulically assisted, and linked directly to a complex steering gear that let the Tiger turn or pivot without power loss. Most Allied tanks, by comparison, used rugged but primitive systems, clunky manual transmissions that fought the driver at every move. The Churchill's Merritt-Brown system, though reliable, required heavy handling. The Sherman's gearbox was robust but coarse. The Tiger, however, moved with an elegance that seemed impossible for a 57-ton machine. In Farnborough's metallurgical labs, microscopes revealed why. The gear teeth were ground to microscopic smoothness. The surface hardness, measured by Vickers indentation, showed a case-hardened layer reaching 1.2 millimeters deep, perfectly uniform. Beneath that lay a tough core of medium alloy steel, designed to flex under stress without fracturing. The combination was ideal, hard enough to resist wear, soft enough to absorb shock. These weren't ordinary steels. The analysis found traces of molybdenum, nickel, and chromium, strategic alloying elements that improved strength and heat resistance. Each tooth, each bearing, told the story of an industrial system still rich in resources, despite the tightening Allied blockade. One metallurgist, in his report to the Ministry of Supply, noted that the gears are finished to a standard rarely seen outside of aircraft manufacture. Another remarked on the precision of the bearing seats, ground to tolerances within microns. The entire assembly reflected an understanding of metallurgy that prioritized smoothness and durability over simplicity. And yet, that very perfection came at a cost. British engineers soon realized how complex this gearbox truly was. Each assembly required careful alignment, specialized tools, and immaculate machining. Even a small miscalibration could cause catastrophic wear. Where the Allies had opted for mass-producible reliability, the Germans had chosen mechanical artistry, a machine designed to fight like a Stradivarius violin, not a factory hammer. The more the British examined it, the more questions emerged. Why would Germany, under immense wartime pressure, pour such effort into a design that was so difficult to build and maintain? Was it a product of pride or desperation to prove superiority through technology? Documents retrieved from intelligence sources hinted at the answer. Henschel's engineers had been under direct orders to deliver a tank that embodied unquestionable dominance on the battlefield. Every element, from its overlapping road wheels to its massive turret ring, was meant to inspire fear and demonstrate technological mastery. The transmission wasn't just a mechanism, it was a statement of engineering ideology. Back in Farnborough, the disassembly continued. The Henschel L600C steering system was next. Its double differential design allowed the Tiger to steer by varying power distribution between tracks, a revolutionary concept for such weight. When British engineers tested it on a stand, the motion was eerily smooth. The Tiger could pivot 360 degrees on the spot, its movement controlled with the delicacy of a wristwatch. To those who witnessed it, it was almost unsettling. Here was a weapon of war that behaved like a luxury machine. As the weeks passed, the metallurgists filed their reports. Gear micrographs, chemical composition tables, and hardness profiles piled up. A dossier of German precision. Every sample confirmed the same truth. The Tiger wasn't just built stronger, it was built smarter. That realization left an impression far beyond the laboratory. Because what the British found in that gearbox would soon reshape how they thought about tanks, power, and the very philosophy of engineering in war. The answers weren't just in the metal, but in the minds that forged it, and that was where the true investigation began. The human angle in the quiet test bays of Farnborough and Chertsey, the Tiger's gearbox lay exposed like a specimen from another world. Around it stood men whose tools were not rifles or grenades, but micrometers, hardness testers, and metallurgical microscopes. These were the unseen soldiers of the war, the British, metallurgists and engineers whose victories came in laboratories rather than on battlefields. They had spent years dissecting enemy weapons, 20mm cannons, Panzer IV components, Messerschmitt engines. But this was different. The Tiger was no longer a rumor or a silhouette through smoke. It was real, solid, breathing oil and steel. Every man in that room felt it. The respect, the curiosity, and perhaps a hint of intimidation. They knew that somewhere in Germany, another team of men, equally skilled, equally human, had built this thing with devotion and pride. And now, their work was in enemy hands, being understood and unmade. The process was almost reverent. The scientists handled each part as if it carried a heartbeat. Under magnification, gear teeth looked like mountain ridges, their polished surfaces reflecting decades of mechanical knowledge. One metallurgist noted the precision of the finishing marks. Hand-lapped, likely checked by experienced machinists rather than mass production. "You can almost feel the man behind the tool," he wrote. For these British engineers, the Tiger was more than a trophy. It was a mirror, reflecting what human determination could achieve under any flag. And as they documented every alloy, every tolerance, they were reminded that wars weren't just fought by soldiers, but by craftsmen, scientists, and thinkers locked in silent duels of ingenuity. The tactical angle on the battlefield. The Tiger's gearbox wasn't merely a mechanical marvel, it was a weapon multiplier. Its transmission and steering gave it a kind of agility no other heavy tank possessed in 1943. Where most 50-ton vehicles struggled to turn without grinding to a halt, the Tiger could pivot smoothly and engage targets from nearly any angle. British tank crews had seen this firsthand. Reports from Tunisia described Tiger tanks pivoting on their tracks, guns swinging in perfect coordination, firing before the enemy could even aim. It was a terrifying sight, a machine that moved not like a lumbering beast, but a predator choosing its next kill. The Maybach Olvar gearbox, combined with the Henschel L600C steering unit, allowed the Tiger to maintain traction and control even while turning. Power was distributed variably between tracks, enabling precise continuous rotation. To the driver, this meant less fighting the controls and more commanding the vehicle's behavior. To the gunner, it meant a stable firing platform that rarely jolted or skidded offline. On paper, these seemed like technical details. In practice, they changed everything. British armored doctrine had long emphasized massed maneuver, formations of multiple tanks advancing together, covering each other's flanks. The Tiger, however, turned that logic upside down. It could dominate a battlefield alone. Its mechanical precision gave it the poise of an artillery piece on treads, stationary yet deadly. In post-capture trials at Chertsey, when British crews test-drove the Tiger, they immediately felt the difference. The controls were heavy, yes, but predictable. The machine obeyed. One test driver recorded in his notes, "Turning radius remarkably fine. Feels alive, not resistant." That single phrase, "feels alive," captured what Allied crews had feared most. The Tiger's strength wasn't only in its gun or armor, it was in its smoothness, its ability to move with purpose, to feel controlled, even calm, amid chaos. This precision gave German crews the illusion of invincibility, and it gave the British analysts a new understanding of how mechanics and morale could intertwine. The technological angle, technically, the Tiger's gearbox represented a leap forward in armored design philosophy, one that the Allies hadn't yet caught up to. The Olvar OG-40-1216 wasn't simply about transferring power, it was about managing it. The preselector system allowed drivers to shift gears with minimal interruption in torque delivery, maintaining traction and smooth acceleration. Inside the housing, helical-cut gears reduced noise and distributed load evenly along their length, minimizing vibration, a crucial factor in aiming the gun accurately. British engineers noted the quality of the materials immediately. The gears were made from chrome molybdenum steels, case-hardened to resist pitting and wear under massive load. Even after thousands of kilometers of service, the surfaces showed minimal fatigue. Bearings were of high-grade steel, finely ground and lubricated with precision. To replicate such standards in wartime Britain would have required time and resources that no factory could spare. The Tiger's gearbox was essentially over-engineered, a marvel in theory but an expensive indulgence in practice. Still, the lessons it offered were invaluable. Allied reports from 1943 to 44 noted how German design focused on optimizing driver control rather than simplifying production. This understanding directly influenced later British and American designs, especially the Centurion's powertrain philosophy: smoother, stronger, easier to handle. From a purely mechanical standpoint, the Tiger's gearbox was a symphony of balance. Torque, precision, and endurance in perfect ratio. But beneath that beauty lay its flaw. Too delicate for the brutal demands of a prolonged war, too complex to sustain under bombing raids and material shortages. It was both genius and hubris forged in steel, and as British metallurgists wrote their final notes on the gearbox, they began to look beyond its perfection, toward the meaning of such engineering in the context of war. Because the next phase of their study would reveal not just how the Tiger worked, but what it meant. 4. The enemy angle inside those cold British laboratories. One unspoken truth lingered. Every curve, every gear tooth, every bolt they studied was the work of an enemy engineer, a man who had likely believed his creation would ensure Germany's dominance. The Tiger was more than a tank. It was the embodiment of German industrial confidence, the physical form of an ideology that saw precision as proof of superiority. Its engineers, many drawn from firms like Henschel, Maybach, and Krupp, had grown up in the golden age of German mechanical excellence. They were trained in a culture that worshipped tolerances, obsessed over surface finishes, and treated machinery as art. That culture bled into the Tiger's design. The gearbox was not designed merely to function. It was designed to excel, even if that meant exceeding logic or cost. While British and American engineers built for efficiency and field repair, the Germans built for performance. It was a mindset forged long before the war, from pre-war industries that prized craftsmanship above all. Even under air raids and resource shortages, Henschel's production floors maintained inspection standards that bordered on perfectionism. Every gearbox was hand-fitted, tested, and calibrated. The cost in time and materials was immense, but the result was a tank that felt alive under its crew. To the British metallurgists, this realization carried a quiet awe and a warning. If Germany could pour such effort into a single machine while fighting on multiple fronts, what else might they be capable of when their industry reached full war footing? Yet there was irony too. That same obsession with excellence slowed production, limited numbers, and made field maintenance a nightmare. Each Tiger that rolled off the line was magnificent, but it also demanded hours of upkeep, specialized tools, and expert hands. In the end, the Tiger's gearbox reflected the psychology of its makers. Brilliant, confident, but trapped in the illusion that perfection could overcome practicality. It was a masterpiece born from a doomed philosophy. 5. The moral resource. Angela's 1943 turned to 1944. The British metallurgists began to notice something else in the Tiger's steel: the faint chemical fingerprints of scarcity. Early samples contained ample nickel and molybdenum, essential for hard, resilient alloys. But later German gear steels showed substitutions: vanadium instead of nickel, and lower-grade chromium content. Each substitution told a story. By 1944, the Allied blockade and strategic bombing had strangled German access to critical materials. What had once been the finest alloy steels in the world were now being diluted, recycled, or replaced. The Tiger gearbox before them, likely built in late 1942, represented a moment of industrial peak. But it also revealed how far the German war machine had already begun to stretch itself thin. In their reports, British scientists noted how the case-hardening processes, carburizing and quenching, remained exceptional, but the base steels were beginning to show inconsistency. The heat treatment marks varied slightly from component to component, a sign that even the best factories were feeling the strain. Morally, it struck the engineers in a strange way. They realized they weren't merely examining a machine, they were reading the enemy's industrial heartbeat. Every trace element, every microscopic imperfection, was a message from deep within the Reich's foundries. It revealed desperation masked by brilliance. And in that contradiction, they saw both the strength and fragility of the enemy. The Tiger's perfection, they understood, came not from abundance, but from defiance. It was a machine built to declare, "We are still strong even as the walls closed in." That insight carried weight beyond engineering. It showed how war distorts genius, how human pride can drive technology to its zenith, even as the nation behind it begins to collapse. The comparative angle. When the British completed their analysis, they compared the Tiger's powertrain to their own. On one side lay the Ulvar gearbox, complex, intricate, whisper-smooth. On the other stood the Merritt-Brown system used in Churchills and Cromwells, simpler, coarser, but reliable and quick to manufacture. The differences spoke volumes. In Allied tanks, gears were machined for function, not beauty. The design priority was field repair. A mechanic with a wrench could strip and reassemble a transmission in hours. In a Tiger, that same task could take days and required factory-level precision. But there was no denying the superiority of German motion. British test drivers found that the Tiger's transmission gave it an uncanny grace, the ability to creep forward at 1 mile per hour, then accelerate smoothly without lurching. That slow crawl allowed it to fine-tune aim, adjust cover positions, and exploit firing angles that Allied tanks could never manage. In combat terms, that meant first-shot accuracy, often the difference between victory and annihilation. Still, the British learned quickly that sophistication didn't always equal success. When the Tiger broke down in field trials, as it often did, its magnificent gearbox became a liability. Spare parts were rare, alignments difficult, and tolerances unforgiving. So while the Germans had built a masterpiece, the Allies had built an army. That realization shaped post-war tank design philosophy across the world. The British began to combine German precision principles with Allied pragmatism. The result would emerge years later, in the Centurion, and eventually, in NATO standard tanks where performance met maintainability. In the Tiger's transmission, the British found both inspiration and caution. It taught them what to admire and what to avoid. And as the last gears were catalogued and stored, one thought remained among the scientists. If a machine could embody both the genius and downfall of its creators, this was it, because understanding why the Tiger felt unstoppable meant understanding the human cost behind that illusion of perfection. Climax, Section 1. The moment of realization. The day of the first full mechanical test arrived under a gray English sky. The Tiger had been reassembled with surgical precision, its gearbox cleaned, re-lubricated, and aligned to factory specification. The vehicle rested on rollers inside a hangar at Farnborough, its exhaust stacks aimed toward open doors. Around it, engineers and officers gathered in heavy coats, their notebooks ready, the air heavy with expectation. When the engine roared to life, it didn't sound like a tank. It sounded like an aircraft, a deep, clean surge. The Maybach HL-230 breathing through tuned carburetors. No stutter, no uneven cough. The entire hangar trembled. The test driver, a veteran from the Armored Corps, eased the preselector lever forward. The gearbox responded instantly. Smooth engagement, no grinding. The tank rolled, shifted, and turned with fluid grace. The sound of meshing gears was so soft it could barely be heard over the idle. Those watching realized in that moment what had made the Tiger so terrifying on the battlefield. It wasn't just the gun or the armor. It was this, the calm, unbroken rhythm of motion that let the tank feel invincible, even under fire. When the Tiger turned on its own axis, the floor beneath them vibrated with perfect symmetry. No jerks, no lag, just continuous rotation. For the first time, the British saw how German crews could aim, fire, and reposition with uncanny precision. Then came the metallurgical data. Hardness profiles showed the gear teeth at 720/760 Vickers, ideal for surface durability under immense torque. The base metal, medium carbon steel with chromium and molybdenum, showed excellent fatigue resistance. Microscopic analysis revealed no decarburization, no internal flaws, and near-zero variance in grain structure. Every reading confirmed what their eyes had already seen. The Tiger's transmission was a masterpiece of controlled energy. But it wasn't just the numbers that struck them. It was what those numbers meant. The British engineers were used to thinking in terms of trade-offs. Lighter weight meant lower strength. Faster production meant looser tolerances. The Tiger defied that logic. It sacrificed everything, speed, cost, simplicity, for pure performance. As they tore deeper into the technical reports, the magnitude of that decision became clear. The Ulvar gearbox's preselector mechanism used an intricate hydraulic servo system to handle shifts, something no Allied tank possessed at the time. That meant minimal driver fatigue, consistent torque transfer, and no loss of control under combat stress. The Germans had designed the Tiger not as a machine for soldiers, but as a machine for masters. At Chertsey, one of the senior engineers, after reviewing the reports, wrote a single line in his notes. "It behaves like a precision instrument, not a vehicle." That realization sent ripples through the British design offices. For years, Allied doctrine had viewed tanks as expendable, tools of maneuver, numbers over nuance. The Tiger flipped that idea on its head. Here was a tank that treated mechanical perfection as a weapon in itself. The more they studied it, the more uncomfortable truths emerged. The Tiger's steering system, with its double differential control, allowed curves of motion mathematically precise, a feat no Allied tank could achieve in 1943. It gave German gunners the ability to align within seconds, making ambushes lethal. Even the clutch system, multiplate and finely balanced, ensured minimal torque loss, translating engine power into relentless motion. When the engineers compared these figures to British tanks, the differences were glaring. A Churchill could deliver about 35 horsepower per ton. The Tiger, nearly 13. Yet the German design felt more powerful because it wasted none of it. Its efficiency was the real weapon. That was the revelation. The Tiger's unstoppable reputation wasn't magic. It was metallurgy, precision, and the pursuit of smooth power delivery. As test logs filled with data, another layer of insight appeared. When they pushed the gearbox to simulate battlefield stress, it responded predictably. No chatter, no slippage, even at torque loads near 2,000 Nm. Allied gearboxes, under similar strain, would often seize or shear teeth. Then came the microscopic metallography. Thin sections, etched and viewed under polarized light. What they saw resembled artwork. Crystalline lattices perfectly balanced between martensite and ferrite, the result of controlled heat treatment known only to a handful of German factories. That's when one metallurgist leaned back and muttered softly, "Now I see why it never breaks." But the realization was bittersweet. The Tiger's excellence was undeniable, yet so was its vulnerability to its own brilliance. The gearbox required oil so pure that field units often ran dry, its tolerances so tight that mud and dust could jam the selectors. It wasn't a weapon built for a long war. It was built for short, decisive victories. Still, the British couldn't help but feel a measure of admiration. The Tiger's gears were more than mechanical parts. They were philosophy in motion, precision over quantity, perfection over practicality. And as the tests concluded, a new question emerged. What would the British and their allies do with this knowledge? Because now, they didn't just understand the Tiger, they understood how to defeat it. Climax. Section 2. Translating Discovery into Doctrine. When the final reports were compiled, they were stamped top secret and circulated through a small circle within the Ministry of Supply, the Department of Tank Design, and select armored training schools. The findings weren't merely technical, they were strategic revelations. The British now knew exactly why the Tiger seemed almost unstoppable, and, crucially, how to exploit its limits. The data showed that the Tiger's gearbox and steering systems, while extraordinary, came with fragilities. The complexity of the preselector mechanism meant that a single misaligned servo, a hydraulic leak, or a seized bearing could immobilize the entire vehicle. The tolerances that made it smooth also made it delicate. From these findings came new tactical doctrines. Tank crews were instructed to avoid head-on engagements, to attack mobility, not armor. Artillery units learned to aim for the suspension and tracks, knowing that once halted, a Tiger could rarely move again without factory-level attention. Air reconnaissance began marking likely repair depots, knowing that each lost gearbox could cost the Germans weeks of work. Instructors at British armored schools integrated these lessons into field training. The new mantra spread quietly through manuals and lectures. The Tiger is not immortal, it is magnificent and vulnerable. The technical data also reshaped design thinking across the Allies. British engineers realized that smooth power delivery, not just raw horsepower, was key to combat effectiveness. In the workshops of the fighting vehicle proving establishment, they began experimenting with more efficient gear systems, better clutches, and torque management, ideas that would later appear in the Comet and Centurion programs. American observers were equally fascinated. Engineers from the U.S. Ordnance Department reviewed the British Tiger reports and cross-referenced them with their own findings from destroyed German tanks in Italy. They drew similar conclusions. German engineering had prioritized precision at the expense of production. The Tiger's gearbox required an estimated 2,500 man-hours to manufacture, nearly 5 times that of the Sherman's, transmission. This was the other half of the realization. The strategic economy of design. Every Tiger that rolled off a German assembly line consumed enough precision labor to build several Allied tanks, and while Germany pursued perfection, the Allies pursued scale. The results of this philosophical divide were already visible on the battlefield. In 1944, during the Normandy campaign, the Allies could field thousands of tanks against a few hundred Tigers. The British and Americans accepted mechanical imperfections as the price of victory. something the Germans, bound by their obsession with precision, could never fully embrace. Still, the Tiger's influence lingered. Its gearbox inspired both fear and fascination. And for good reason. When British engineers ran endurance tests, the Ulvar transmission lasted nearly twice as long as its Allied counterparts before significant wear appeared. Even under full torque, the contact surfaces of its gears showed uniform polish, not scoring or pitting. It was an engineering masterpiece, even by post-war standards. But what mattered most wasn't what it did. It was what it revealed. By understanding how the Tiger's transmission worked, British strategists began to decode the rhythm of German warfare itself. The Wehrmacht's approach mirrored its machinery. Precise, deliberate, confident, but slow to adapt when conditions changed. Once the Tiger's gearbox philosophy was understood, the Allies knew how to counter it. Through chaos, through attrition, through relentless production and flexibility. Reports circulated to command units emphasized this new logic. German tanks, though technically superior, were often immobilized not by combat but by breakdowns and logistics. The British understood why. The very design that gave the Tiger its poise also made it intolerant of field realities. Dust, mud, heat, and rushed maintenance. In one field test, engineers deliberately contaminated the Tiger's gearbox oil with sand and soot to simulate desert conditions. Within minutes, the smooth preselector began to seize. The result was conclusive. The Tiger's brilliance depended on purity, of materials, of lubrication, of assembly. In the chaos of war, such purity could not survive. This became the pivot point, the true climax of their discovery. The Tiger's apparent invincibility was an illusion built on perfection that war could never sustain. Still, the British refused to dismiss what they'd learned. In their design rooms, they adopted the Tiger's best lessons: tighter tolerances where needed, smoother steering integration, and improved metallurgy for gears and bearings. The Centurion tank, which would soon emerge, was the living proof of those lessons applied with pragmatism. At the same time, the reports urged humility. They reminded commanders and designers alike that even the enemy's greatest weapons could teach valuable truths. Not through imitation, but through understanding. The final summary of the Farnborough analysis closed with a single understated line: "The Tiger is a monument to what precision can achieve, and to what perfection cannot sustain." That sentence, quietly circulated, captured the essence of the war's industrial struggle, a war where one side built marvels and the other built victory. And so, as the Tiger's gearbox was crated and stored, the men who had studied it understood that they had witnessed both brilliance and futility entwined in steel. What they had uncovered was more than engineering. It was the psychology of a nation, its triumph and its tragedy, measured not in ideology, but in the cut of a single gear tooth. Aftermath. Section 1. Numbers. Losses. Shifts. By mid-1944, the Tiger's legend had reached its peak, its silhouette haunted. Allied crews across Europe, from the bocage of Normandy to the fields of the Eastern Front. Every destroyed Sherman or Cromwell seemed to carry the whisper of an unseen tiger lurking just beyond the hedgerows. Yet, behind that legend, the British engineers at Chertsey and Farnborough now saw a different truth, one grounded not in myth, but in metallurgy. They knew how the Tiger moved, why it felt unstoppable, and, more importantly, why it couldn't last. When the Normandy campaign began, the Germans fielded fewer than 150 operational Tigers across the entire front. By comparison, the Allies landed with over 6,000 tanks and could replace losses within weeks. The British intelligence summaries reflected this imbalance bluntly. The Tiger inspires fear far beyond its numbers. Still, that fear came at a cost, for both sides. Every Tiger required an immense logistical chain. The gearbox alone needed exacting oil quality and regular maintenance intervals that the chaos of retreat could not afford. Field reports from German units, intercepted and translated, revealed the growing burden. Crews complained of overheating transmissions, stripped gears, and shortages of spare bearings. The very system that made the Tiger superior also made it fragile. In desert and mud, fine dust infiltrated servo valves and bearings, locking the preselector. In winter, the gearbox oil thickened, delaying shifts. What had once been a triumph of engineering became a liability in the unpredictable rhythms of combat. Meanwhile, the British were applying their hard-won knowledge. Anti-tank tactics evolved rapidly. Artillery units focused on mobility kills, hitting drive sprockets and track links rather than trying to pierce the frontal armor. Infantry squads were trained to exploit the Tiger's limited turning ability in tight terrain, using smoke and flanking maneuvers to trap it. At the same time, engineers in the United Kingdom were incorporating their lessons into new designs. The Comet, which entered service in late 1944, carried a more efficient transmission and better weight distribution. The Centurion, finalized after the war, would perfect the balance between firepower, armor, and mobility, the very triad the Tiger had once dominated. Statistically, the Tiger's record was extraordinary but deceptive. It often achieved kill ratios as high as 10-1, but these numbers masked the broader truth. Germany could not sustain such machines. Each Tiger cost over 300,000 Reichsmarks to produce, roughly 3 times the cost of a Panzer IV and 6 times that of a Sherman. Production numbers reflected the strain. Fewer than 1/400 Tigers were ever built, compared to over 49,000 Shermans. For every Tiger that rolled off the line, the Allies rolled out dozens of tanks, repaired others, and replaced their crews. Quantity, reliability, and logistics, not mechanical perfection, were winning the war. Still, the psychological effect of the Tiger remained unmatched. Captured crew diaries from Allied tank units spoke of hearing its engine from miles away. A deep, rhythmic growl that made men tighten their grip on the controls. Even when the Tiger wasn't there, the fear of it shaped decisions, routes, and morale. The British scientists at Farnborough understood this psychological war better than anyone. Their reports, later declassified, noted that the Tiger's perceived invincibility came not just from its power, but from its smoothness. The human mind associated that lack of mechanical strain with invulnerability. A lesson as psychological as it was mechanical. That insight would later influence tank design philosophy itself. Smoothness became synonymous with reliability, predictability with control. The engineers who once dissected the Tiger's gearbox would go on to advocate for driver ergonomics, power-assisted controls, and intuitive mechanical responses, lessons drawn directly from their enemy's most feared weapon. By the war's end in 1945, most Tigers lay abandoned or destroyed. Some were captured intact, others blown up by their own crews to prevent recovery. But in Britain, one remained, Tiger 131, preserved not as a trophy of conquest, but as a monument to engineering itself. It had once terrified armies. Now it sat quietly in a museum workshop, its gears resting in oil, its perfection still gleaming under the lamps of those who had once feared it. But the war had changed, and so had the men who studied it. Because the Tiger had taught them not only about steel, but about the limits of human ambition when perfection meets reality. Aftermath, Section 2. Engineering Echoes. When the war ended, the laboratories at Farnborough and Chertsey were quieter, but their shelves remained lined with fragments of German machines, including the Tiger's gearbox. It was no longer a weapon to be feared, but a reference, a benchmark. In 1946, British technical officers compiled a final synthesis of all German armored engineering. The Tiger's transmission occupied an entire chapter. The report described it as a system of remarkable precision, designed without compromise to performance. That document would quietly influence the next decade of tank development across the Western world. In British design offices, the lessons became tangible. The Centurion, often called the best post-war tank, bore the intellectual fingerprints of the Tiger's examination. It combined smooth power transmission with field serviceability, perfection tempered by practicality. Its gearbox, though simpler, owed its fluid operation to principles first seen in the Ulvar design. Likewise, steering systems in later NATO tanks borrowed from the Tiger's dual differential concept, balancing maneuverability with mechanical resilience. But it wasn't just about machinery. The study of the Tiger had reshaped how British engineers thought about engineering itself. It taught them that every choice, every bolt, every curve of a gear, was a reflection of philosophy. The Germans had chosen mastery, the British sustainability. In the end, the latter had won. Still, admiration remained. Even years later, retired metallurgists who had handled Tiger components spoke of them with quiet respect. One recalled the moment he examined a polished gear tooth under magnification. You could see the care. It was as if someone, somewhere in Kassel, had wanted that piece of steel to be perfect, even if no one else would ever see it. Such reflections weren't romantic. They were human, because buried within that perfection was a paradox. The Tiger was both the pinnacle and the downfall of German engineering, a machine that embodied the best of mechanical science and the worst of strategic obsession. By the 1950s, the Tiger's influence had spread beyond Britain. American engineers who reviewed the British reports incorporated similar precision-to-practicality balances into their own designs. The M48 Patton's transmission system, for example, borrowed principles of torque modulation and durability under continuous load, lessons traced back to those Farnborough documents. Even the Soviets studied the Tiger closely. Captured examples from the Eastern Front were torn apart at Kubinka, yielding similar conclusions. Impressive, but unsustainable. Their own designs, such as the T-54, took the opposite path. Mechanical simplicity with mass reliability. The Tiger had inadvertently become a teacher to its enemies. At the same time, the surviving Tiger 131, now fully restored, became more than a museum exhibit. It was an artifact of a moment when engineering ambition met human frailty. Its gears still turned, its engine still roared, but now the sound meant something different. It wasn't fear. It was remembrance. Visitors who watched it move saw not just a machine of war, but a machine of meaning. The men who built it were gone. The men who studied it had passed their lessons forward. Yet the Tiger remained. Still teaching, still humbling those who thought they understood what perfection meant. For historians and engineers alike, the Tiger's gearbox became a symbol, a reminder that in war even brilliance must bow to the limits of time, supply, and circumstance. The smoothness that once terrified tank crews now inspired designers to seek balance, not dominance. In 1943, the Tiger's gears had whispered of power. In 1945, they told of exhaustion. Today, they speak of legacy, of how knowledge, once born from conflict, can evolve into understanding. Because the Tiger's greatest lesson was never about superiority, it was about the cost of pursuing it. And in that realization, the engineers at Farnborough found something unexpected. Respect not for victory or defeat, but for the relentless pursuit of mastery that defined an age of steel and sacrifice. In the end, the Tiger's gears became more than relics of machinery. They became symbols of human ambition, the kind that burns brightest when surrounded by darkness. When British metallurgists first turned those polished teeth under a microscope, they weren't just studying steel. They were staring into the mind of an enemy who believed perfection could win a war. The Tiger's gearbox was the purest expression of that belief. Precision without compromise, control without mercy. But history has a way of humbling even the most perfect machines. For all its brilliance, the Tiger could not outlast the laws of war. Logistics, time, and the will of ordinary men who built simpler, humbler machines by the thousands. And yet, there is something profoundly human in the Tiger's story. Behind its perfection was pride, behind its failure tragedy, and behind its cold metal, a trace of beauty that engineers on both sides could recognize. The British scientists who once dismantled its gears would go on to design new tanks, new tools, and new philosophies, each carrying a piece of the Tiger's lesson. They learned that mastery lies not in complexity, but in balance, not in domination, but in understanding. Today, when Tiger 131 rumbles to life at Bovington, the last of its kind still running, the sound no longer carries the fear of 1943. It carries memory, the echo of men who built, fought, studied, and learned. Standing beside it, you can almost feel the continuity. The same oil, the same steel, the same heartbeat of human invention. The difference now is that it no longer divides, it teaches. Because the Tiger's story isn't just about how machines fought a war, it's about how humanity learned from them. In the gleam of its gears, history left us a quiet truth, that the pursuit of perfection can make a machine unstoppable. But it is understanding, not power, that makes us enduring. If you enjoyed this deep look into the engineering secrets behind history's most feared tank, make sure to subscribe for more real, cinematic stories from World War II, where every machine, every battle, and every decision shaped the world we live in. Drop a comment below. Do you think the Tiger's perfection was its greatest strength, or its downfall? And if you'd like to see how Allied engineers turned these lessons into the Centurion, the tank that would redefine post-war warfare, stay tuned. That story's coming next. Like, subscribe. Keep history alive.